Yes. Let me zoom in. Can everyone see this? Yeah.
Um, Can you make that abbreviation?
Yeah.
Okay. There
Yeah.
are some that are really good practice. So we encourage you to do the ones that are good practice. Okay. Just because when you're working with other people and they see import seaborn as born, they're gonna be like, what is born?
Yeah. Yeah, for sure. Let me know if you guys want me to zoom in more.
It's all good because people in the back see it. Thank you.
Okay. I'm also going to do this. It's just so my plots can like come up inside my thing. I think it's like a different command for Max, but don't like worry about it too much. Like it should still render everything okay. Okay. So now what I'm going to do is I'm going to try to plot this thing. And to do that, I'm going to define an X and a Y axis, and I'm going to use np.meshGrid to define to define my X and Y. So does anyone remember from last lecture how we defined like the range for our axes? There was like two kind of ways we could do it. Okay. So Um, not quite. It's like when we're trying to like define like a range of values where I want to be like, I want X to be from 0 to 100. Yeah. Yeah, you could do a range and you can do linspace. So I'm going to do linspace just because that's like easier for me to kind of conceptualize, but we'll talk about the difference later if anyone has a question about that. So np.linspace starts at negative. I'm gonna make it start, my range start at -1, end at -1, and have 100 spaces in between. With a range, it's a little bit more complicated. It's like a different like yeah.
This includes like 1 and 1 or -1, right? Like it doesn't exclude it.
Let me quickly check. Yeah, so it includes -1 and it also includes 1.
What's the difference between like a range and linspace?
Let's see.
The difference between a range and linspace is that one of them, the third argument is a step. So like you can say, okay, go from 0 to 100 with one, with a step of 1. So then you end up with 100 objects. And then the other is you define how many samples you want. So you can go from 0 to 100 with 100 samples. I never remember which one's which, so I always look up every single time. It's
So does that make sense? A range is like if you want to define it based on your step size, and linspace is based on how if you want to do it with the number of points that you want to have. So I wanted kind of, I mean, I could do some math and try to figure out with linspace, a range, but I'm just gonna do it with linspace for now. So I defined my linspace to be for the x-axis to be from -1 to 1, and then for the y-axis, I'm gonna define it to be from -2 to 2. And that's just because I'm following what is plotted over here. Cool. Now I'm going to define my z-axis, which is just going to be x plus y. Yeah. Oh, because I'm just defining my z as my f, my function. You can totally write z. I can write z if that's like less confusing, but this is kind of just like my function. Any questions? Other questions? Okay, cool. Let's try to plot this. So again, does anyone remember like the command plt dot I'll splash the slides again. So we're gonna do plt.imshow to plot our function, which I define to be z. And another really cool thing about imshow is that I have like all these options for color maps. And if you go to the slides, there's like this link that shows you all the different color maps. So you guys can like pick your favorite one. I'm going to do, let's see. I 100% agree. I like Inferno the most. So I'm going to do, yeah. Okay, sure. So yeah, so when I want to start plotting, I want to start by like defining like a figure. And then I'm going to do like my plot statement. And then I'm also going to define my C map. And again, you guys can do it as anything. I'm going to do Inferno. And another aspect about imshow is that there's like different colors going on, and we want to be able to define to like the viewer like what these colors represent, which is why you'll need like this color bar thing. And in order to display the color bar thing on in your code or in your figure, you just have to call plt.colorbar. And then finally plt.show, so we don't get like that statement. And let's run it. And ta-da! So let me zoom out a little bit so you guys can see it, and then I'll zoom in for the code. Uh-oh. Sorry. It's also good coding practice to label your axes, so let's do that too. I'm just gonna call it x-axis. So, ta-da, that's my image. It kind of looks similar to this guy, but it's in a different C map. The C map is Vertis. I used Inferno. So I'm gonna pause here for like a minute and just let you guys absorb what we just did and take any questions. Yeah.
Why would say that matplotlib has no attribute imshow? Matplotlib.py. Make sure you import it as matplotlib.pyplot as PLT. Cool. That's generally image.
Yeah. Yeah. So, like I said before, what's happening in this plot over here is that I have a 3D axis. I'm sorry, I have a 3D plot, but I'm just like squashing it so that I can't see like the depth of it. So like we're kind of just looking at like a bird's eye view of what this plot would look like. So I'm gonna pull up an example because I think this is really important to understand. Sure. Yeah, I'll just wait for you to put it. Okay.
I mean, I guess it could. Okay, that's a really great idea. I'm sorry, it's hard to see in the back. Can you select like open in browser? I did this for Radio Lab, which if you're an astro major, you have to take one of the labs. Radio Lab is one of them. I spent 12 hours here taking data on the sun. The color represents the power of the sunlight, so how much power is hitting the telescope. This axis is frequencies because we've taken, we can see how much power is coming in at what frequency. And then the y-axis is time. So basically, this is showing sunrise to sunset of some power in frequency channels. There's a lot of things in astro and in and other fields, because I know we're not just astro here, where having 3 pieces of information, sometimes more, is really important to be able to show. Does that make sense? Also, it's just a cool plot.
Does that kind of make sense? Yeah. Does anyone want like another example for this is a really cool one, but does anyone want like another example for what mesh grid is doing? Let me see. I saw some good examples as well. Oh, okay. This is a good example. So here we have a you're good, you're good. So here we have this 3D plot of kind of like a saddle looking thing. And then what we're gonna do is that what's happening in our code is that we just take the X and Y, which is just us getting a bird's eye view of this thing, and it kind of flattens the image. So I wish I could show a bird's eye view of that, but um so like I guess this is also another good example. This image is actually just like an upside down cone that's kind of coming out like this. But we're looking at it from the X and Y axis only, so we don't really see like the depth of it. The depth is portrayed through the different colors. Yeah? Yes. There's like a 3D another 3D plot. Did we ever release the Oh, this is another good example. You guys can soak this in. Did we ever release the plotting guide? Okay, so there's a plotting guide, and over in that plotting guide, it's like the coolest thing ever. It has like everything that you'll ever need to know about plotting. And there is like a thing where like it lets you plot 3D plots just like this one. Any other questions? Okay, cool. So, um, there are other things that you can do with imshow. Like there's other parameters that you can manipulate, which is like origin and extent. I'm gonna let you guys kind of like explore that on your own, maybe in the homework and stuff. But let's try to let's try to attempt this question together as like so like I'll let you guys do work on it for like 5 minutes, and then we'll come around and answer any questions. But just to get started on it, like what I would recommend is just taking the code that we just wrote and like copying it into like another cell, and then just like manipulating like the things that are different in this question. Okay, go for it. Feel free to talk to the people around you and raise your hand if you have any questions.
Yeah. Oh, this is great. Yeah, that's very like a accurate here. But I'm trying to figure out what the number. How do you do screw? Yeah. How do I do screw? Yeah, screw root. Okay, no.
Maybe we try to the 1/2 power. I didn't try it. Should I try it? Should I just run it to try it? Oh, it's saying it's not.
I just figured,
Sure. What is that?
If you have English and that's good.
Oh, it works. It works.
Oh, it does?
They're doing this, yeah.
Oh, okay. Yeah,
Oh.
powering that makes sense.
But can I do like?
Oh, yeah, that did work. Got this.
Well, no, I haven't done that yet. But wait a second. I'm gonna run it. Oh, no.
oh, I got this.
Oh, fine. Wait, hold on. Would you prefer for you the next?
Okay, if you do empty dots.
Oh, you also put it there. Hold on. Yeah, I didn't.
Then NP or no. When you get PLT dot fix. And PLT dot.
Intro. Yeah.
Okay, and
What are the names?
I would love to know.
Yeah, see, I mean, this is like kind of.
Is it not called?
I think so.
Oh, it's just going up. One of them is called seaborn. One's just called pot.
I know.
The plasma looks the same as the.
Plasma does look-
Sequential.
Those are the-
I'm gonna try.
I'll try twice.
And then I forgot the rest of it. I can do it. Let's see, PLT.
No. Oh, I like that.
It's good.
Oh, video. Okay. Wait, why were you?
Oh, because I set my my boundary from so
I tried to Yeah. start with this, but I used it. I didn't like that. I feel like it makes it.
Why do we need the color?
Oh. So you can have it. And X, this, you gotta do the double start.
No.
Well, yeah, me too.
Why, wait, how do you guys spell money?
Oh, all you need to do is export this last one.
Oh, it's.
So you need to do the.
I like that. I think that-
So you need to find
It
the.
looks very active this time.
It's like
Ooh.
it's kind
Oh,
of
we just kind of do it. That makes sense. That's all.
That's a good one.
I wonder, what
Wait,
would you say that?
Customers said, yeah, just like choosing from lines, like everyone is like.
Oh, wait, 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 wait.
Large.
I'm sorry. Yeah, don't wait, can I see what you're saying?
Your size.
Yeah.
Yeah, so.
Did I not?
It's truly, it's.
Oh, right.
Yeah.
What is called?
Oh, it added this.
Yeah.
I like this is good.
So it basically looks like this.
Oh, it's like a silver. What?
Oh, my.
Yeah. Yeah.
Oh, it's colors.
Look at the list.
Like, I like it very.
Oh.
See?
That was cool.
Yeah.
That looks like
This one?
Yeah,
Yeah.
it does.
It's like, it feels like I like this.
Yeah.
Oh,
Outside.
Right.
Yeah.
I see, okay.
The bodies.
It's the same, man. Let's try to guess that bar.
Wow, that was like,
Yeah, that's what I was, and then.
Get that. And there's like, kind of like.
This is my favorite. I like the one how to read. It's just. And it's like.
Oh, you got it.
It's not big enough.
Sorry. Yeah, yeah. We did. Okay.
What was my shift?
yeah, basically it's just inverted.
Yeah. That was you.
All right, we're gonna regroup now. So, the way how we do this question is we first want to redefine our x and y to be, I think, from -5 to 5. Correct me if I'm wrong. For both x and y. And then I want to do the circle function, which is x squared plus y squared to the power of half. And we get something like this. Does anyone have any cool C maps that they want me to try over here so I can display? I saw some cool C maps. Yeah. Oh, cool. I'm sorry. I was like, cool. Oh, very cool. Does anyone have any other ones? That's a cool one. Do you want to show yours?
Okay, I think there's two that look that. Called Prism.
Like this? Oh. So if you guys want something like this, you can try Prism. And what's the other one? Like that?
Yeah.
Ah. Okay, cool stuff. Cool stuff. So I'm gonna go back to cool for a second. So I got a question that asked me, why is it that, because okay, this is kind of like what we're plotting right now. It's a circle, but in the 3D axis, it should kind of go like this. And the question was asking like, why is it that like the lowest level is kind of in the middle? And my guess for that is I think like maybe I don't know why that's, do you guys know?
Take the derivative so equal to 0. Maybe that's what.
Mm. Yeah, I think it's probably like maybe if I did this, I don't know what's gonna happen. Okay. I
It's higher work.
so I think it's just I think maybe like the z-axis is just being weird about it. We can like sit down and do the math, but I can't really tell you right now. But yeah, maybe I'll like make an ed post later. Sorry? Really? What about them? Oh, it's like go because it's 100 points. So it's going all the way to 100 is my guess. Yeah. The axes. Okay, I'll like kind of toggle with this a little bit tonight, and then I'll make an ed post explaining it, hopefully. But aside from the depth confusion, does anyone have any questions about this? Okay. Yeah, my guess for that is because it's 100 points. So we're doing if you wanted to again, if we go to the imshow documentation, we can use things like origin and extent to kind of do it like specifically for what we want it to be. So, let's see.
Wait, Lachlan, what did you define the mesh grid?
It's in the same, yeah, right here.
Try defining it underneath PLT off here. So just define all of that. Yeah.
Really?
I don't know, man.
I don't think that should make a difference. But yeah, you guys don't need to overthink it. I'll figure it out tonight and make it ed post. But the gist is we just plotted a circle in 2D-ish, kind of. Does anyone have any other questions? I know like what's confusing right now is the leveling and like the axes. But aside from that, does anyone have any other questions? Which kind of sucks, so they're pretty important questions. Okay. Okay, cool. So how do we feel about imshow and plotting in 3D? Good? Bad? Okay. Okay, that's great. I saw some thumbs up. So now we're gonna talk about statistical plots. So what we've been doing, there's like a lot of ways we can plot things. Like you can do a lot of ways you can plot discrete data, like bar graphs and scatter plots, and there's like also other ways like these things. So what we're going to do now is kind of plot, we're going to generate data and we're going to plot plot it using like different what's it called? PLT things. So this is where SNS comes in. So we're going to use SNS, which is how we're going to load in data. I'm going to make a new cell. I'm going to call this we're going to load in penguin data. Yeah. And then I'm going to use SNS to load a data set called penguins. And I'm also going to kind of print penguin data so I know what it looks like. Yeah, so SNS is a package that we imported at the beginning, and it has data.
What is it? Like is it like on the internet sort of?
You can think of it like that. It's like a package that like lets you load data sets, and then you can like there's like specific data sets that are available that you can load in.
You have to know what's available.
Yeah, you can just Google it. Yeah. Yeah. I'm sorry. I will zoom in. How's that? Okay. So now we're going to make a bar graph of the island versus the body mass. And to do that, I'm going to use sns.barplot. I'm going to define the data argument to be our penguin data. And I'm going to define my x-axis to be literally copy-paste island. And then I'm going to define my y data to be, oh no, copy-paste, I can type, my body mass for each penguin. I'm going to zoom out a little bit to show the bar plot, but ta-da. So this is kind of, I like to think of Seaborn as kind of like a crutch. So when we start loading in our own data, like, I don't know, if you ever take stellar physics, you're gonna like load in like data about stars and you'll get like axes that has like information about the star's luminosity, the star's mass, blah, blah, blah. So you're going to load that in using like a specific, however you can use pandas, you can use NumPy, and then you can kind of like the same way that we're dissecting through this data, you're going to determine like what are the axes of my data, and then you're going to use plt.plot and you're going to define your x-axis and then your y-axis, and you're going to kind of plot it using plt.plot. SNS is, I think, is like a good crutch because we kind of have generated data, and again, we're defining our data to be penguin data, and then what's really important is our x and y axis. Does that kind of make sense? Is this going over anyone's head? Yeah. I don't know what that would look like with discrete data. I mean, this like specifically this kind of data. I don't know what you would have as your third axis, but you could do it with like other data if that's what the nature of the data is. Yeah. Any other questions? Yeah.
This body mass or total body
I did body mass, but you could also do average. I don't know, even, is there even average? I don't see an average body mass. Is there any specific part that someone wants me to zoom in on so they can copy it? Yeah.
Oh, when it's giving you like out in brackets
Yeah.
and it says axes, is that like a suggestion to label your axes? Or what does it tell you?
It's usually, I'm not familiar with SNS, but like, because so basically it's kind of just like the output of this bar plot that's coming out. So if, for example, I didn't have plt.show over here and I ran the cell, it kind of gives me like this function looking thing where it prints the last statement of the thing. But if I don't want that to be there, I use plt.show to kind of clean it up the graph. Does that make sense?
Is there a similar thing?
I'm sure there is. I just have to look into it. So I don't know if you guys are familiar with Seaborn. How do we get rid of this thing with Seaborn? Because it's not a plt.show thing. It's a, oh, cool. It is.
The last thing that you run, it evaluates and it spits back out like what
Oh,
it returns.
yeah. Did you guys hear what the Charlie said?
I can repeat it. I like talking. I'll just repeat it because I like talking. Basically the reason you had that line at the top was because the last thing that your cell output or that your cell saw was plt.show. And whatever that returns, it's going to print out and it's going to plot it. So plt.show wraps it all up into a nice little box so that you don't see any of that messy in between stuff. But what you were seeing was the axes image or the axes object that you were plotting. Does that make sense? It's okay if it doesn't. You don't necessarily need to know this. Just if you want it to look clean, put plt.show.
Okay. Any other questions? Yeah, it's like so you can label the, I believe, or maybe it's the error range. I'm not sure. Do you guys know why there's like dashes at the top?
Those are error.
Right?
Yeah.
Okay, those are error bars.
Oh, you're using seaborn. Oh, I don't know.
They look like error bars. Okay. So you can do bar plot. There are other things to do that you can use with SNS, like count plot, and I don't know, you guys can Google SNS like plotting things, and then it will have all of the different ways you can plot your data. I'm going to stop here so you guys can ask any question. Actually, I can keep talking about the different plots. Okay. Another thing that kind of like this is kind of like coding practice with statistical plots, but sometimes you'll want to basically, instead of your axes kind of showing kind of like over here, I have this really long like kind of curve thing. If I can just log my y-axis, it will kind of appear like a straight line. And you can basically scale your axes with PLT by just like going like I don't know the command off the top of my head, but it's kind of like you can scale your axes to better represent what your data is trying to show. Does that make sense? Yes, exactly. And whenever you guys do end up scaling your axes, make sure that you're kind of communicating that in your labels. This is really important. Like whenever we make plots, we can't leave we always have to label our axes, we always have to label our plots, our the title of the plot, and we always have to label what each line represents on the thing. So that's just like a rule of thumb for all plots. Anytime you're ever coding a plot for a class, if you guys are not labeling your axes or anything, they will mark off points and you'll be upset. But like, it's justified because if you just give me like a plot with like a circle on it, I have no idea what's going on. So always make sure to label your axes using like plt.x label, plt.title, plt.what label, and then you can basically like make it all pretty and everything, but just make sure you're labeling that stuff. Does anyone have any questions on like how you can label axes or anything? Like everyone remembers that from last lecture, right? Okay. Okay. So we talked about seaborn. There, you can make bar charts, you can make count plots. I'll upload these slides into B courses so you guys can kind of like discover it on your own. And you can also, for box plots, this is kind of a quick refresher. You have your outliers, your minimum maximum, and then your IQR, all just like basic statistics stuff that plt.sns.boxplot automatically does for you when you pass in the data. Okay. Cool. So next time in discussion, you guys will plot something really cool. I'm not going to spoil it for now, but if you have any questions, please do stick around. And you guys are free to go.
It's also office hours today through work, you know? Yeah. What's it? Oh, also final project proposals, they are due very soon on Friday. Just a reminder, if you weren't here on Monday, it is Wednesday, yes it is. If you decide, hey, this actually doesn't work for me, then you can always change it. You just have to talk to us first. The point of this proposal is to get you guys used to starting to write proposals for research. You also, we will be going over loading data in a future lecture, so don't worry too much about that. Just keep an eye out. Yeah, and any questions about pilot projects can either be emailed or you can come up to me and ask them now. Cool, go home, or no, it's 11 a.m. So go to class.
Yeah, I have a question about the lens.
Yeah.
Oh,
So
also, one last thing, homeworks will be due on Fridays now. So, I'm still gonna release them. I'm still gonna release homework 6 today, but, they will be due, homework 6 will be due not Wednesday of next week, but Friday of next week. Cool, thanks, guys.
Kind of confused because like when you're doing -5 to 5, like what this, I know that 100 means like the number of elements in that. But like the -5 to 5, I'm a little confused.
yeah, so if I just print out my list space from -5 to 5, I get a range. I get like 100 values that start at -5 and end at 5. So it's just like 100 values in that range.
How do we control like the steps between like each?
Yes. So if you wanted to control like the step size, which in this case, I just wanted 100 points. So I just used this. If I wanted to control, like, let's say I wanted it to be NP dot, I wanted it, so I'm going to first of all use something called a range. And let's say I wanted the step size to be like every one number. Then bam, I get -5, -4, -3, blah, blah, all the way to, it's not including the last number. Does that make sense?
Yeah, okay. So for the lens space, all these numbers are just kind of randomized then.
No, they're not randomized. It's like basically taking the, so like if,
Between -5 to 5.
and then dividing it by 100.
Oh,
So it's like a constant amount, but it's super like small because it's 100. It's trying to like
I see.
find
I see.
100 points between two
Okay.
numbers.
Can we use lens space, but then instead of like, but like for example, a value of like 0 to 2 pi.
Yeah.
1,000 elements. Then we just do 0 to pi 1,000, and then that's gonna.
So you're saying if I do 0 to 2 times 2 pi, I can get 100 points from 0 to 2 pi.
Oh, okay, I see. Oh, okay. Okay.
Yeah.
Thank you. That
Yeah,
makes
of
sense.
course. Have a good day. What's up? Third floor. Yeah.
Thank you. Those slides are gonna be posted on.
I'm posting it right now.
Okay.
Yes. Oh,
Jacob.
my bad. Fifth floor.